Hey guys, Mr. Royce here to help you out with the third day of the 2.2 note. So now that we know how to take the derivative and we can take derivatives of crazy equations, we want to make sure we still understand and can apply the properties of derivatives. So remember, the derivative can tell us the slope at any point. So now that we can find the derivative super quick, we can use that to find the slope of any point and use that to find the tangent line. So remember when we did these problems, what we had to do first was to figure out what the derivative was, plug that x value into the derivative, and then do y equals mx plus b. Well, this is going to be a whole lot easier because the difficult part was figuring out what the slope is. Now that we know the equation to find the derivative, so let's see this one here, x to the fourth would be 4x cubed, then minus, all right, multiply the 2 by the 3, 6x to the first, and then the 2 would go to 0. That's the derivative. We didn't have to go through the limit process. We're done now. All we need to do is to take 1 and plug it in. So let's see, f prime of 1 would be 4 times 1 cubed minus 6 times 1, or aka 4 minus 6. And so the derivative, when we evaluate at 1, would be negative 2. That's what our slope is. So we can use that with our x and our y. Let's see, y would be 0 and x is 1 to solve for b. And we'd get a 2 that we'd add over, so b would equal 2. So we can find these equations of tangent lines a whole lot quicker now using our slope from our derivative and plugging it in to find out our b. Okay. Now, since we can do it super quick, we can even do it super quick with even more difficult problems. So if I got 2 over the fourth root of x cubed, so that's 2x to the negative 3/4 power. All right, so, think about the difficulty that, we'd have to find a common factor and a conjugate and all that other mess to figure out what this one would be. But power rule says the derivative y prime would be, all right, 3/4 times 2 would be negative 6/4, or negative 3 over 2. X to the, drop it down, negative 7 over 4 power. So the derivative here is negative 3 over 2 times the fourth root of x to the 7th. This is why it's important to rewrite. Now what we're going to do is take our x value, plug it in, and we can find our slope. So negative 3 over 2 times the fourth root of 1 to the 7th. This is just going to become 1, 2 times 1. So we're getting negative 3 over 2 is our slope. So now we can use y equals mx plus b. We found our slope by taking the derivative and plugging in our x. And we'll take the points with our x and y, so 2 equals m, once again, is negative 3 over 2 times x is 1 plus b. All right, so we'd have to add that 3 over 2 over to 2, or add a 1.5 over. We get 3 over half, or 7 over 2 is b. So our final answer is y equals negative 3 over 2x plus 7 over 2. Whole lot easier now since we have these power rules. All right, another thing we're going to look at here is not just, tangent lines and figuring those out, but we want to find out horizontal tangents. This is going to be a very key step into taking the derivative and what the derivative can tell us. So if we think about a horizontal tangent is when the slope is flat, or aka the slope is 0. So that means the derivative is going to equal 0. So we're going to we're not going to take a number and plug it in for x. What we're going to do is take the derivative here. So let's look at this equation that we got. The derivative here is, let's see, this would be 4x cubed minus 4x, and then 0. What we're going to do to the derivative is set this equal to 0. So we're going to find the points where we would have horizontal tangents. So the points value, let's see, how do we solve this one here? Well, this one we'd factor out a 4x and we get a x squared minus 1. And we could keep factoring and we get 4x equals x plus 1, x minus 1. So we actually get 3 times where we have horizontal tangents, when x equals 0, when x equals negative 1, when x equals positive 1. Now it does say find the points. So after we find the x value, sometimes we just want to know the x value, sometimes we want to know the points. If it's finding the points, we want to figure out where these are on the graph. All right, so we're going to take those points and plug them back in. So let's plug 0 back into the original equation. 0 minus 0 plus 3, that'd be at 3. All right, let's plug -1 in. -1 to the 4th is 1. -1 squared, okay, that would also be 1. So it would be 1 minus 2 plus 3. See, 1 minus 2 is -1. -1 plus 3 is 2. Positive 1 give us the same answer? It would be. All right, so actually, you know what we should do here is let's double check this on Desmos before we move on to make sure we understand what's going on. So let's pull up Desmos here. Look at the graphing calculator. Ooh. You know what I'm going to have to do is let's do some fancy work here. Let's get rid of all of our work. Delete. Let's take our answers. Ooh, can I slide them over? I hope I can. There we go. Let's see. So the graph is, oh, I gotta get my mouse back. X to the 4th minus 2x squared plus 3. Let's zoom out so we can see the graph. Ooh. Oh, I put plus 2. That makes a difference. Minus 2. Hey, there we go. So if we click on these right here, we get -1, 2. 0, 3, and 1, 2. If you look, all those would be flat horizontal tangents. That's where the graph changes directions. Cool. All right, one more problem here to do. Let's set this up. Okay, what about does 1 divided by x squared equal horizontal tangent? So let's change this to x to the -2nd power. So we take the derivative of this. We get -2x to the -3rd power. So we're going to set this equal to 0. When does -2 over x cubed equal 0? We actually run into a predicament. Because if we try to cross multiply here, we would actually cancel out. And then we would get, there's no way we can take a number or 2 divided by anything to get 0. So this just does not exist. There are no horizontal tangents. And that happens sometimes. So what we're going to do to find horizontal tangents, you take the derivative and set it equal to 0. And let's actually look at Desmos on this problem here. So if I look at just straight up, there's the Joshua Perry podcast. Very good. He's a good Speaker Ohio State football player. If I take 1 divided by x squared, 1 divided by x squared, we look at this graph. Now it looks like when we get very, very far out, it gets flat, but technically is never horizontal. It's still going up. And same thing here. We have a vertical asymptote, which is not horizontal at all. It's quite the opposite. And same over here. We can get really close to being flat, but we will never actually get a flat horizontal tangent. Because even if we keep getting close, zoom up very, very close, you can see it's still going down. The numbers are slowly, slowly changing, getting lower and lower. All right, guys. So this wraps up the 3rd day. We got one more day when we start looking at other applications of the 2.2, but I'll see you guys next time. Have a great day.